Hey everyone, welcome back. So till now we have learned some basic concept. Today we are going to learn advanced topic which is Sieve of Eratosthenes. Okay, so this is related to the prime number itself. So how this is going to helpful for us, we are going to look into it. Okay, so before moving to this concept, let's solve a problem which will be related to this concept. Okay, so you have a problem like you have given a number 30. Now you have to print number of primes till the 30, means 2 is the prime, 3 is the prime, 5, then 7, 11, 13, 17, 23, 29, and there is 19 also. So these are the number of primes we have till the number of 30. So you have to print number of primes. So here we have 3, 6, 9, 10. So we have 10 prime numbers, so you have to print 10. Basically you have to print count of prime numbers till the number 30. So how we can solve this problem? So basically we have to check all the number till the 30 if it is a prime or not, right? So we have to run a loop. Let's take a num. Let's start from the 2 itself because 1 is not a prime. Less than equals to 30 and num plus plus. So this will increase our number by 1, means initially we have 2, then 3, then 4, then 5, then 6. So it will run our loop from 1 to 30. Now we have to check that every number is a prime or not, right? For this we had a code here. Okay, let's use that code itself. I think this is our code, right? So let me copy paste from here. So first we are running our loop from 1 to 30. Okay, then we are checking every number which one is prime or not. So for that we had a code to check a prime number. So we used a count method, right? If a number is having exactly 2 factors, we can say it is a prime. So now we here taking num, right? Here we are taking count, which is counting the number of factors. Now we are running our loop from 1 to root of n. So this time we are solving for a number, right? Solving for this num, right? So we will write here num. Now after that we will check if it is a factor or not. So here we also write num. If that num is completely divisible, we will increase our count, and if that same number is dividing the n and is not equals to the I, we can also increase our count, right? So now we have to take one more variable which will be counting the number of prime itself. So we will declare one more variable here, answer equals to 0, right? After checking prime, or we can say after counting the factors, let me rephrase it, counting the factors. Okay, if count is equals to 2, we can say it is a prime factor. If it is a prime factor, we can do a answer plus plus, else we don't have to do anything, right? Because we want only number of primes. After that we can end our loop here. So let's dry run it. Okay, so let's take a number 5. Okay, so that means this loop will run 1, 2, 3, 4, 5. Now we have to filter the prime from these numbers. So for that, okay, our loop will run from 2 itself because we are starting from the 2. Now here we have I equals to 1, I into I less than equals to num. So initially our num is 2, right? So this loop will run from 1 to root of 2, right? So basically it will be a I into n divided by I into 2 equals to 2. Here 2, we don't have to go beyond this, right? Because this is repeating, this method we have learned, right? So we have to go till root n. So here our count will become 2. One count will increment from here and second one from here. So our count will become 2, and if we check count equals to 2, our answer will become 1, right? So we can say we found one prime number. So now our loop will continue, and num will become 3, and same will keep running. So this was the concept we have learned, right? So the only changes in this code is this outer loop, right? Because this time we have to check prime for every number till the 30 or any n number. So we will pick a single number, then for that number we will check prime. If it is a prime, we will increase our answer count. If it is not, we will skip it, right? And this loop will keep running till the 30 itself. So now what is the time complexity of this code? This loop is running for the big of n, right? Because it is running from the 2 to 30 or n number of times, and we know the time complexity to check a prime number, it is a big of root n, or it will be a big of root num, but in the worst case it will become big of n itself, right? Because our num will go till the n, and so the worst time complexity will become root n. So our overall time complexity is big of n root n, and space complexity is big of 1, right? So in that way we will be able to count our number of primes till the number of n. N can be any number. This code is same to check a prime, but we just have to write one more loop. You can say supply us numbers. On that numbers we can check it is a prime or not. Okay, first let's write this code, then we will see how we can improve our time complexity. Okay, so let's remove this. So we have n till which we have to count the number of primes. Okay, after that we will declare answer variable which will be storing the number of primes. Then we will be running our loop num, and it will be going till the n and num plus plus. So it is kind of supplying us a numbers 2 3 4 5 6 7 8 till the n numbers, and on that number we have to check if it is a prime or not. So for checking a prime we have already written a code. So we will be using our concept of number of exactly two factors for the prime. So let's write our loop here. So we will start from the 1, then I into I less than equals to num. Okay, so we are running our loop till the num itself. Okay, if you have num 2, so our loop should run square root of 2. If we have num 16, our loop should run till the root of 16. Now we will here I plus plus. Then after this let's check for a factor. So we are checking a factor of num, right? So num modulo I equals to 0. We can say it is a factor, so we will do a count plus plus. Also check for a n divided by I not equals to I, we can do a count plus plus. Okay, after this loop we will check if our count is exactly 2, so we can say it is a prime number, so we will answer plus plus. After completing both of the loops we can write answer. Okay, so now let's run our code. Let's take 30 here. Here you can see it is printing me a 10. So till the number of 30 we have 10 prime numbers. Let's take input as a 5. So till the number of 5 we have 3 prime factor, 2 3 and 5 including. So this code is only counting the prime. So let's modify it. Okay, so let's try to print our prime also. Now let's run it. Let's take 11. So till 11 we have 2 3 7 11 0. Okay, there is maybe some mistake. Let's run it again. Okay, it is a printing 0 from that answer. Okay, so now let's run it again. Let's take 5. So it is printing 2 3 5. So in this way we were able to count the number of primes. We were able to print our primes. Now the time complexity is n root n. Now I want to improve the time complexity to the n log of n. Okay, this log of n is better than the root n, so we have to improve. So for that we have a concept of sieve of Eratosthenes. Okay, so now how we are going to solve this problem, count of primes, using sieve of Eratosthenes. So for that, before going to the code, let's see how this concept works. So let's take our number 30. Let's create a array, and we also have 0 1, right? Let's create an array and let's write indexes here till the 30 index, right? And mark all the blocks with the 1. Okay, now the concept is if a number is having factors, it is not prime, right? If there is any number which is having factors, we can say it is not a prime. We don't need this, right? We will start our loop from here itself. Now we know 2 is the prime number, but 4 is not a prime number, and 4 is a factor of 2. 6 is not a prime, also it is a factor of 2. 8 is not a prime, also it is a factor of 2, right? So basically we will pick a number. Let's say we have picked a number 2. After picking a number, we have to eliminate all the numbers which are having factors of 2. So our 4 is a factor of 2, so we will make it a 0. 6 is having a factor of 2, make it 0. 8 is having a factor of 2, make it 0. 10 also having a factor of 2, 0, 12, 0, 30, 0 means every number which is having factor as a 2, we can make them as a 0. Right, after doing it for a 2, let's move to the 3. For the 3, we have 6, then we have 9, then we have 12, then we have 15 here somewhere. Right, so this one already 0, now this one will be 0, this one already 0, then there is 15 which will be 0. Right, now let's take 4. We cannot take 4 because 4 is already 0. If 4 having 2 as a factor, that means all the numbers which are multiple of 4 also having 2 as a factor, so we don't have to take a 4. Now let's come to the 5. So 5, then 10, then 15, then 20. Right, so this is already 0, 15 is already 0, and any other number is already 0 except 25 somewhere. Okay, so 25 will also become 0. Now after that, let's pick 7, then the multiple of 7 will be 0. Then 8, we cannot pick 8 because it is already 0. We cannot pick 9 because it is already 0. We cannot pick 10, then we will pick 11. Right, then we will do a 0 for the multiple of 11, then similarly with the 13 and so on. So now if you carefully observe that the number which are still having value 1 are the prime numbers. Right, 2 is prime, 3 is prime, 5, 7, 11, 13, these are the prime. So the number which is still having 1 as a value, they are the prime. Right, so basically this concept eliminates the numbers which having a multiples. Okay, now let's write a code and we will see some of the logic in the code. First we have to build this array. Right, so we will create array with the name of prime and we will have size of n plus 1. Right, because we are going till the index number 30 and we are starting from the 0, so total size is 31. This is 31. Okay, so that's why we are going to the n plus 1. If you go till the n, this index will be removed and it will go till the 29, but we have to check till the 30 itself. In this case it is a 30. 30 is not a prime, no problem. If it is a 13, if you have taken n equals to 13 and the index, it would have been gone till the 12. Right, so the 13 will not be included and 13 also a prime number, so you have to take n plus 1 here. Okay, now we will run a loop. Let's take from 2 itself because for 0 and 1 we don't have to do anything. We will go till the n and assign with the value of 1. So we created this array. Okay, now after this we have to pick every number, right, and check the multiple or eliminate the multiple. So we will run our loop again from the 2 and we'll go till the n. Okay, now we have to write here one condition, prime of I equals to 1. Now why we are using this condition? So when we were at the 2, we made 4 as a 0. So next time our iteration was at the point of 4, we wasn't taking the 4 because it is already 0. So it is checking if the number which is still having 1, we are only making the multiples of that number 0. Right, because 4 is already 0, so we don't have to go for, let's talk about 5. 5 is having a value of 1, so we can say it is a possible prime. Okay, that's why we are checking, so we can skip our numbers which is having 0 as a value. Okay, because if you don't use this, you will be then removing the number which has already removed. Right, so you have to write this to make sure you don't jump onto the number which is having 0 value. After this we will run another loop. Okay, which is basically doing a jumping. Right, means we have I here which is 2. Now we have to jump to the multiple of that. Now so our initialization from which number? Right, because initially our I was at the 2. Okay, let's start from the I. So till which number it will be going? Till the n itself. Right, now what is the update condition? We are starting from the I going till the n and then we have to update. So we are at the 2, then we are jumping at the 4, then 6, then 8. So what is the jumping condition? For this it is plus 2 plus 2 plus 2, which is equivalent to I itself. So we can say it is plus I and plus I. Right, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. So we can say our loop will update with the I, right? Let's take another example. Let's take 3. 3 will jump to the 6, then 9, then 12. So it is a difference of 3, so it is equivalent to I. So we can say j plus equals to I. So our j is updating on the base of I. Now after writing this loop, we will do our prime of j equals to 0, right? Because the main goal is, this concept is doing a 0 multiple of that number, so we will make it 0, right? Because from this we are jumping to 4, 6, 8, 10, 12, so we have to make them 0. So here we are doing a 0 because the number which are 0 is not a prime. Okay, let's end our loop. Now let's take example. This is my array. Let's take 0, 1, 2, 3, 4, 5 till the 6, and we will make them 1. Okay, so we were able to do it till here. Now let's come to this loop. Now we are running from the 2 itself, right? So we don't need this. We will start here. It will check it is a 1. Yes, it is a 1. Then it will come inside this. Now our j will start from the 2 and it will jump with the I, right? So initially at the 2, then it will jump. Now there is one fix we have to do. If we are at 2 and we are deleting multiple of that 2, so we don't want remove our 2, right? Because 2 itself is a prime number. Here what's happening, if we have j equals to 2, it is making it a 0. If our 2 becomes 0, then it is saying it is not a prime number, right? So you can see we cannot start our loop from the 2, or we can say we can start, but we cannot make our numbers 0 from here. We have to make our number 0 from this number itself. Okay, so our initialization will change, so it should become I into 2. Okay, so if we have I equals to 2, it will become j equals to 4. So from this number we will start making 0. Okay, let's take another example. Let's say we are at the 3. Okay, now after 3 we have start making from 6 itself, so it is 3 into 2, which is 6. Okay, so let's take like this, for I 3 or 4 5, right? So if you do a multiply of 2, it is 4, it is 6, and it is 10. So we are making 0 from this number itself, not the number from the I itself. Because if you try to make number 0 from I itself, so our 2 will become 0, 3 also becomes 0, 5 also becomes 0. That's why we have to do here I into 2, right? So our initialization will not be from that I itself, but from the next number of itself, right? So if we have I equals to 2, what is the next number of I? It is 4, right? So we just have to do a multiply of 2. So our initialization is from the next number of that I. Okay, so here we will do a into 2. Now let's dry run it again. So we are here. Okay, it is a 1, true. This time we have I equals to 2. Our j will start from the 4 itself. Okay, and it will make it a 0. Okay, that's fine. Now our j will jump from 4 to 6, then j will become 6 and make it a 0, right? So we have done for the I equals to 2. Now let's take 3. I equals to 3, so we have here equals to 1, true. So that means we can go inside. Now for this we will start from the 6 itself, right? But 6 is already 0. Now if we try to jump, we cannot, right? Because there is no more values, so it didn't have to do anything. So now let's take I equals to 4 here. Here you can see 4 is already 0 and it is comparing for the 1, so this loop will not execute. Then we will jump with I equals to 5, then j will start from the 10, but 10 is not available, right? So our loop will end here. So if you check a array with the value 1, you will be able to find your prime numbers. Now we can do two more modification to improve our time complexity. So here you can see we are able to find our answer till this number, right? Till 2 itself. After 3, 4, 5, we have already eliminated the multiples related to this number. So we can say we just have to go till the square root of n, because all the multiples already have been marked 0. So we don't have to check beyond the root n. Okay, so we don't have to check the beyond the root n because all of them are 0. Because in this case you just have to go till 2 itself, and 2 already made the 4 0 and 6 0, right? And 2 3 5 we got our prime. So we just have to go to the root n. So here we can say we have to go till root n. Now let's make one more changes. Let's look at one more thing. We have I equals to 2 like this, and our j is kind of initializing like 2 into 2, right? Then it is jumping to the j equals to 2 into 3 like this, right? Because it is a 4, then it is a 6, then it is jumping to the 2 into 4, it is a 8, right? If we take a I equals to 3, our j will be like this: 2 into 3 6, j equals to 3 into 3 9, j equals to 4 into 3 equals to 12, right? Similarly for 5 into 2, 5 into 3, 5 into 4, 5 into 5. So here you can see for I equals to 2, we have 6 here. Similarly for I equals to 3, we also have 6, right? So let's take 7 also. 7, then 5 into 5, 5 into 6, 5 into 7, 5 into 8, then 7 into 2, 7 into 3, 7 into 4, 7 into 5. Here let's take 5 into 3, right? So what I'm saying, for I equals to 2, we have 6 here. For 3 also we have 6 here. For 3 we have 15 here. For 5 we have 15 here. So this 5 into 2, it already have been included in this 2, right? So we have already seen 5 into 3, we have already seen 5 into 4, 20, which will be also seen in the I equals to 2. So you can see that we don't have to start our loop from I into 2 itself. We just have to start our loop from I into I. Because if you look at it, 2 into 2 4, here 3 into 3, here 5 into 5, after here somewhere 7 into 7. If you look at this number, 2 into 3 6, it has already been covered. 5 into 2 10, it is already been covered. 5 into 3 15, it is already covered. 5 into 4 20, it is already covered, right? So what I am saying, the number above this number is already have been covered in previous I itself. So we don't have to start every time from I into 2. We can start I into I. 2 into 2, 3 into 3, then 5 into 5, then here 7 into 7, because 7 into 5 35, 5 into 7 already covered. 7 into 4, it already covered in 3, right? 7 into 3 already covered in 3. 7 into 2 already covered in 2. So these number are already covered, right? 14, 21, 28, 35. These number already have been covered. So we don't have to start our loop from here. We can start loop over here, which is I into I. So here we will make changes and do a I into I. So this is our final code with the time complexity of n log of n. Okay, so we will go till the root n and we will jump from I into I itself. Okay, dry run it yourself on a bigger number, 30, 31 or 24, any number, and then you will be able to understand why we are doing this. Okay, so let's write our code. So let's remove all of it. So we are taking n as an input. After that we are declaring a array. So we declared array of n plus 1 size. Then we will run our loop. Let's start from the 2 itself, because for the 0 and 1 we don't have anything. Then go till the n, then I plus plus, then we will assign values as a 1. Now let's run another loop. I equals to 2, I into I. We are going till the root n, then I plus plus, then we will check if that number is 1 or 0, right? Because if it is a 0, means it already have been marked 0. So for that number we don't have to do anything. Now let's run another loop. Int j equals to I into I, j less than equals to n, j plus equals to I, right? We are jumping based on the I and marking them as a 0. Okay, now let's declare our answer variable and let's run our loop once again till the n I plus plus, and we will check if it is equals to 1, that means it is a prime, right? After this we will print our answer. Okay, let's run it. Let's see if it is working or not. Let's take 30. Okay, not working. I think there is some problem. It is j I into I, j less than n, j plus equals to I, marking 0, root n. We are checking for a 1. Okay, here it should be j, not a I. Okay, now let's run it. Let's take 30. Here you can see it is giving me the 10, which is correct. Let's take this time 2 only. So we have 2 only, right? Okay, let me make some changes and show you why we are doing here I into I. If I do a only I, okay, here if I only do a I, and if I run my code, let's take input 2. Here you can see it is still giving me the 1. Let's take input for 7. For 7 it is giving me a 3. It is a correct answer. 2, 3, 5, 7. It is skipping one of the prime number, right? So you should make sure it should be from I into I, because it is also removing your one of the prime number. Okay, that's the code. Also you can print your prime numbers also. Prime, okay, so we have prime number in the indexes itself, so we will print I here. Let's run our code. 2 3 5. Okay, so that's it for this code. Okay, I hope you able to understand it, because it is really complicated implementation, right? The logic is simple itself, but the code to write this logic is little complicated, because you have to understand this logic, how we are jumping over the numbers and mark them as a 0. Okay, so our time complexity is big of and log and. Okay, how this time complexity came, no one is going to ask, but if you want to study it, you can search on the Google itself. It is called prime harmonic series. Okay, until then, thank you everyone, have a nice day.